All right, so here what we're going to do is refer to the revenue and profit functions that were in example 3. So, we've got cost function C of x is 7,000 plus 2x. The price function little p of x is 10 minus 0.001x. Well, revenue is going to be what? Well, revenue is going to be how many items we sold, x, times the price of each one of those items. So that's going to be basically our x times our 10 minus 0.001x. And so sometimes what we like to do is we want to multiply that out. So when we take the derivative, it's easier because it looks like down here we're going to be taking derivatives. So that's going to be what? Well, that's going to be 10x minus 0.001x squared. Okay. And then P of X is really just the revenue minus the cost. And so we have that minus that, which ends up giving us this for our profit function. Now, let's go ahead and find derivatives. So R prime of x is going to be what? Well, we take a derivative of that, we get 10 minus 0.002x. So that's going to be our marginal revenue. And our marginal profit, our P rather, P prime of x is going to be what? Well, that's going to be a minus 0.002x plus 8. Okay, so that'll be our marginal profit. And so now what we're supposed to find is the marginal revenue and profit at specific values and then interpret the results. All right, so let's hopefully we can get everything written here. So R prime of 3,000 is going to be what? Well, here's our R prime, so we plug that in. That's going to be 10 minus 0.002 times 3,000. And that's going to give us, if we plug that in, that gives us a simple 4. And so what does that mean? Well, it means the marginal revenue is going to be 4. So that means at a production level, of 3,000 units in this case, a unit increase in production will increase what? The revenue by what? $4. Okay. So that's what will happen if we do that. Now we want to do our prime of 6,000. So marginal revenue at 6,000, well, that's going to be 10 minus 0.002 times 6,000. And so what happens here is we end up with a -2. Okay. So when we get that one, because that's going to give us -12, and so minus 10, our 10 minus 12 is going to be -2. And now all that's going to be the same, except it's going to change from 3,000 to 6,000 and increase to decrease and $2. So at a production level of 6,000 units, a unit increase in production will decrease the revenue by $2. Okay. So basically, it looks like what's happened is at one point we're over here at 3,000, and so it's going to increase still. And the next point we're over here and it's decreasing, and so that's going to be what it's looking like. And if you think about what your revenue function is, it's a quadratic with the negative a here, and so that's kind of what we're going to see. All right, so now we want to look at the marginal profit at 2,000 and 7,000. So let's go to the next page because I don't think we'll have enough room to write that. So P prime of x again was negative 0.002x plus 8, and we wanted P prime of 2,000. So if we plug that in, plus 8, that's going to actually give us a 4 again. And so that means at a production level, and now we were of 2,000 units, a unit increase in production will increase because we have a positive the profit, since we're in profits this time, by, and it's going to increase it by $4. Okay. Now the other one I think was P of 7,000. And so that's going to be negative 0.002 times 7,000 and then plus 8. And that's going to actually give us a negative 6. So at a production level of 7,000, oops, that's 70. That's 7,000 in units. A unit increase in production will decrease profit by $6. Okay. All right. So I think that was all they asked for. So let's stop there and we'll come back for more.